Living on the International Space Station is comfortable. You've got air, pressure, and Wi-Fi. But what happens the moment you step outside? Well, this happens. Nothing. You wouldn't explode like in the movies, but you would lose consciousness in about 15 seconds. The water on your tongue would boil, and you'd have maybe 2 minutes before your body shut down completely. To survive out there, you need a miracle of engineering. You need a human-shaped spacecraft. Today, we're doing a deep dive on spacesuits. We're going to break down the 280-pound suit NASA has used for 40 years. I'm going to show you the layers, the life support backpack, and how I actually put one on. And finally, we'll look at the future. The new suits private companies are building for the moon. To understand the suit, you have to understand the enemy. On Earth, we have 5 things we don't think about. Air to breathe, atmospheric pressure keeping our blood liquid, regulated temperature, protection from radiation, protection from micrometeoroids. In space, you have 0 of those things, so a spacesuit has 5 jobs. It has to provide oxygen, regulate pressure, manage temperature, block radiation, and stop debris, all while being flexible enough to tighten a bolt with a gloved hand. NASA started building suits in the 1960s. Each generation improved, but the suit we're focusing on today is the AxEMU, the Extravehicular Mobility Unit. It's been flying since the space shuttle days. It's old, but it works. Now, there are 2 categories of suits. IVA, intravehicular, worn only inside the capsule. These are orange or white pressure suits, just for emergencies. EVA, extravehicular, built for the vacuum. The AxEMU is an EVA suit. It's not designed for walking on Mars. It's designed for floating. And it's the perfect example to understand how life support actually works. Let's start with the structure. The suit has 2 major components, the pressure garment, the fabric body, and the PLSS, the backpack, the actual life support. Before the astronaut even touches the suit, they put on a MAG. That's the maximum absorption garment. Yes, it's a diaper. When you're sealed in for 8 hours, you don't get bathroom breaks. Next is the LCVG. That's the liquid cooling and ventilation garment. It's long underwear with nearly 100 meters of tubing. Water runs through these tubes to pull heat away from the body. Without this, astronauts would overheat inside the insulation. Now, the suit itself. Layer 1, the bladder. It's rubber-coated. This holds the air pressure in. Layer 2, the restraint. Woven fabric. Keeps the bladder from ballooning out. Layer 3, the liner. Protects the inner layers from abrasion. Layer 4, multiple layers of mylar insulation. Looks like tinfoil. Blocks extreme temperatures. Layer 5, ortho fabric. The white outer layer. Same material used in bulletproof vests. The suit is white for a reason. It reflects sunlight. On the moon, temperatures hit 250 degrees. White keeps them cool. The torso is fiberglass. It's called the hut. Everything attaches here. Notice the arms? They have bearings. These are rotating seals. Think of a bendy straw. The joint doesn't bend randomly. It folds in a specific pattern. This is called programming. Astronauts have to learn how to move in this suit, or they waste energy fighting the pressure. The gloves are the hardest part. They have heaters in the fingertips. Without them, your fingers get cold instantly because blood flow slows in a vacuum. The helmet is fixed. It doesn't turn. If you want to look left, you turn your whole torso. And the control panel? It's upside down and mirrored. Because when you're sealed in, you can't look down. So there's a mirror on the wrist. You angle your arm to read the display. I had the chance to visit NASA and suit up in an AxEMU. It is not easy. The suit weighs 280 pounds on Earth. In space, weightless. But here, it's a 2-person job. You step into the pants, the most expensive pants ever made. Then you slide into the hard upper torso, which is bolted to the wall. Someone connects your cooling garment. Then they seal the metal ring at your waist. That's the body seal closure. Then the helmet, the gloves, And finally, the backpack. The PLSS is the spacecraft. Inside that white box, primary and secondary oxygen tanks, carbon dioxide scrubbers, water tanks, a sublimator, which turns ice into gas to vent heat, batteries, radios. Everything must work for 8 hours straight. No errors, no second chances. The EMU is reliable, but it's old. Only 18 backpacks were ever made. They cost $150 million each. For Artemis, NASA's return to the moon, we need something new. Enter AxEM Space. They're building the AxEMU. You might have seen it in black. That's just the cover. In space, it'll be white. The big difference? Entry. The old suits zip up the back. The AxEMU opens like a fridge. You climb in from the rear. It's faster, safer. The gloves are better. The helmet gives you peripheral vision. And the suit is flexible enough to actually squat down and pick up a rock. It's not just an upgrade, it's a redesign. A spacesuit isn't clothing, it's a spacecraft. It has propulsion, it has avionics, it has life support, and it fits exactly one person. We spent 40 years perfecting this machine, and now we're sending it to the moon again. If you want to understand the engineering that makes this possible, the physics of pressure, the math of orbital mechanics, the logic of life support, I highly recommend checking out Brilliant. They helped sponsor this video, and they're the reason I can break down complex topics like sublimators and bearings without losing my mind. If you want to think like an engineer, start today. Link in the description. I'm Rana Asif. This is The Deep Dive. See you in orbit.